Hi everyone, this is Pardeep Singla. I'm a partner solution architect with the global partner solution team of Microsoft. Welcome to Data and AI Roadshow. The main aim of this roadshow is to guide our partners to know about the data and AI products and how they can use these products in their solutions. And one of the topic of this roadshow is data science in Fabric, which we're going to talk about today. And this is the agenda of today's top discussion. I'm going to talk about what is data science in Microsoft Fabric and how Azure ML and data science both products can go together. And then I will give you a brief demo on data science in Microsoft Fabric. So let's jump deeper into the topic and discuss about what is data science in Fabric. As you all know, that Microsoft Fabric is a all-in-one analytical solution for enterprises that cover everything from data movement to data science, real-time analytics, and business intelligence. It offers a comprehensive suite of services, including data lake, data engineering, data integration, all in one place. And so we're going to talk about one of its feature, which is data science in Fabric. So Microsoft Fabric offers data science experiences to empower users to complete end-to-end data science workflow for the purpose of data enrichment and business insight. You can complete a wide range of activities across the data science process, all the way from data exploration, preparation, and cleansing to experiments, modeling, model scoring, and serving of predictive insights to a BI reports. So let me talk about what capabilities data science in Fabric has from the data science flow perspective. So, as you all might know, a typical data science, how the typical data science process works. As a well known process, most machine learning projects follow this process. On the high level, the process involves the steps like problem formulation, ideation, data discovery, and pre processing, then experimentation and modeling, then enriching the data and operationalizing the data, and then business gaining insights. Let's see what Microsoft Fabric capabilities has from data science side. If we look at the first step, which is problem formulation, data science user in Microsoft Fabric works on the same platform as business users and analysts. So data sharing and collaboration become more seamless across different roles as a result. Analysts can easily share Power BI reports and data sets with the data science practitioners. The ease of collaboration across roles in Microsoft Fabric makes hands off during the problem formulation phase much easier. If you look at the next step, which is the data discovery and the pre-processing, Microsoft Fabric users can interact with the data in one lake using the lakehouse items. Lakehouse easily attach to a notebook to browse and interact with the data. Users can easily read data from a lakehouse directly into a pandas data frame, and for exploration, and this makes seamless data reads from one lake possible. A powerful set of tools is available for data ingestions and data orchestration pipelines with data integration pipelines, a native integrated part of Microsoft Fabric. Easy to build data pipelines can access and transform the data into a format that machine learning can consume. Now, if we look at the next step, which is the data exploration, an important part of the machine learning process is to understand data through exploration and visualization, right? So, depending on this data storage location, Microsoft Fabric offer a set of different tools to explore and prepare the data for analytics and machine learning. And notebooks become one of the quickest way to get started with data exploration. Similarly, for the data preparation, Microsoft Fabric offers capabilities to transform, prepare, and explore your data at scale. With Spark, users can leverage PySpark, Python, Scala, R tools for data pre-processing at scales. Similarly, for the seamless data cleansing, Microsoft Fabric offers features which we call Data Wrangler, or code tools that prepares data underneath Python code. You can this experience make it easy to accelerate tedious and mundane tasks. For example, data cleansing and build repeatability automation through generate code. For the experimentation and ML modeling, Microsoft Fabric s- uh, offers ML flow experimentation. And so we have a built-in ML flow experiment with which users can interact to log experiments and models. And we also, in the Microsoft Fabric, we also support Synapse ML, which you all know is an open source library, which is maintained by Microsoft, um, which simplifies massively like scalable machine learning pipeline creation. And for the enrichment and operationalize, notebooks can handle machine learning model, batch scoring with open source libraries for prediction. And to gain insights, Microsoft Fabric offers predictive values can easily be written to one lake and seamlessly consumed from the Power BI reports with the Power BI direct click mode. This make it easier for data science practitioners to share results from their work with the stakeholders, and it also simplifies operationalization. Notebooks that contains batch scoring can be scheduled to run using a notebook scheduling capabilities. Batch scoring can also be scheduled as part of like a data line pipeline activities or Spark jobs. Power BI automatically get the latest production without need for loading or refresh the data. Which is thanks to the direct click mode in Microsoft Fabric. The another important capabilities Microsoft Fabric Data Science has is the Copilot. The value of the Microsoft Fabric Copilot lies in its ability to adapt to the user workflow. Um, so here are the examples I can tell you which provides like where the Copilot provides value. Like for the data exploration, Copilots can generate code for plots and statistics using common Python libraries. Similarly, for the predictive analytics, it can suggest the most appropriate models and also tailor them to your data set in the lakehouse. And also it has a feature chat with Copilot in the chat panel where you can do interactive Q&A for instant insight. Like you can query your data sets interactively, for example by asking what is the distribution of sales across different regions. Copilot can generate the code for you to complete the relevant analysis, providing a visual distribution or a summary statistics. We got this question from one of our partners. Uh, they want to know like whether they should use Azure machine learning or a data science in Microsoft Fabric. I just want to give you first the brief idea, then I can like talk about it. Uh, as you already know about Microsoft Fabric, right? It is a SaaS product which provide you like you can do analytics in one platform. But Azure Machine Learning is a pass service, right, for accelerating and managing the machine learning project lifecycle. It provides like a scalable environment to build, train, and deploy machine learning models. So now the main difference between Azure Machine Learning and Microsoft Fabric Data Science is Azure Machine Learning and Microsoft both are valuable tools for data professionals, but there are significant difference between their functions. While Azure Machine Learning enable users to drive insights and deploy machine learning models, Microsoft Fabric data science serve as a unified tool to carry out data preparation, management, and analytics. These both tools have data science capabilities, but they have different features that cater to different use cases. For instance, Microsoft Fabric is best suited for individuals or organizations that need a single analytical platform to handle data engineering, analytics, warehousing, and science. While on the opposite side, Azure Machine Learning is focused on machine learning workflows and to bring machine learning models into production in a secure and auditable environment. The choice between two services always depend on the job requirement at hand. If you need a comprehensive solution for managing workflow on machine learning model, I feel like Azure Machine Learning is the best choice. But for business that need to prepare, integrate, and analyze data in a single pane of glass, Microsoft Fabric is an excellent solution. But the functionality in Microsoft Fabric regarding data science is a bit more narrow. Both Azure Machine Learning and Microsoft Fabric offer powerful tools to enable users to create value from their data, but one is more targeted towards analysis, analytics, and other is more towards like machine learning. But I will definitely say instead of like comparing like um, whether you should choose one or other, there are scenarios where these products both can go better together. In the next slide, I will talk more about it. Me, let me present you some scenarios where both of these products can go together, and where one product is better than the other product. So now, if you look at the screen, you can clearly see as the ML ML ops need is increasing, you are moving more towards Azure machine learning. But if let's discuss the first case, right, where you are democratizing and scaling AI across your organization by empowering your business decision makers, data pros, and business analysts to enhance decision making with the predictive insights in Power BI. So in this particular scenario, data science in Fabric makes more sense because it accelerates time to value through seamless feedback loops established between data pros and the business analyst across organization silos. And in the case of scenario 2 and 3, if customers are looking to build multiple ML and DL models and operationalize these models or build LLM workflows, I will recommend that you should lead with the with the Azure ML, example ML Ops, RAI, and purpose-built AI infra, prompt flow, Azure OpenAI integration, right? So definitely lead with the Azure ML. You can always attach Microsoft Fabric to enhance data wrangling, data processing, data visualization, data governance, and data pipelines. And on the opposite, if customers are looking to use ML as an extension of data analytics, definitely lead with the Microsoft Fabric and position as a central place for all data workloads. Example like OneLake, ADLS Gen 2, PBI integration. So yeah, those are the three scenarios where both products can go together. So as I discussed about the scenario one, like where you want to generate a predictive insights in the Power BI, you can do all that with the data science in Microsoft Fabric. But when it comes to like when you're inclining more towards ML ops, you want to deploy your model in the production environment. That's where both products can go together. You can do all the data engineering, data discovery, feature engineering process in the data science in Microsoft Fabric. And then when you want to do fine tune your model, enrich those models, then you can deploy those models on the production environment through Azure ML. And whatever the prediction it will come up with, you can always store those prediction back to one lake in Microsoft Fabric, and you can generate a predictive insights on top. Let me give you now one very brief demo on data science in Fabric. So this is the very basic architecture for data science in Fabric end-to-end workflow. On the data source level, where you are fetching the data from a lake house and data warehouse, bringing it on the notebooks, and then you're cleaning and preparing the data for training your model. After your model is trained, uh, you are doing predictive insights and storing the those insights back to your lake house, and then generating a report on top of it. So the prereq for this demo is you should have a Fabric license to play with this demo. So the data set we are using for this demo is the diabetic data set based on like a different input parameters like uh, blood pressure level or the pregnancies and all other different parameters. We are predicting whether the person has the possibility of getting diabetic or not. So this is my fabric fabric sacks environment. um, so you can see I am in the my data science personas. We can like Fabric provides all different personas all together at one place. Right now we are in data science in Fabric, where you can see we can do modeling, experimentation, we can create notebooks, and we can import notebooks. So let's go to jump into our first notebook, which is the ingestion of a diabetic data from any external source. Right now, I'm fetching the data like from uh, from the GitHub library, but your data could be anywhere. It could be on a third party cloud too. So Fabric has the capability to fetch the data from those environments too. So you can see I'm downloading the public diabetic dataset to my file section. um, and after that after loading the data, I am putting into one of the data frame, uh, and then writing that Spark data frame to my Lakehouse Delta table. So you can see the diabetic table got created in my Lakehouse. So the first thing when you come to the notebook, you have to attach your Lakehouse so that you can store your tables and all the files. Then the after bringing your data to your lake house, now the second part is the data processing, right? So we are let me show you. So I am again reading the data from my delta table, and after reading it, I'm checking if my all data types are numericals or a character based, and then I have to pre-processing of those data, right? If those are like character based on columns. So that is the cleansing I'm doing here, and also taking care of the null values or the unknown parameters, right? So just replacing that and doing the feature engineering. So after doing that, I'm saving the process data back to my Delta table as a diabetic process. So you can see my table got created in my lakehouse. After processing the data, now you're gonna train your model. So this is the notebook where we are using a Synapse ML library to train our model, and and then we are using ML flow to register our model. So you are seeing here I'm importing the ML flow library and creating an experiment to log the run. I'm reading the data from my Lakehouse Delta table, which is diabetic process table, and then using the Synapse ML library, I divided my table into a trained and predicted data frame, like test data frame, and then so using the light GB like a decision tree model, I trained my model, and after training my model, you can see I logged my model using ML flow for the subsequent use. Um, then using then I am displaying all the prediction by providing my test data, and yep. So that's what this notebook is doing. Now the last action is left is like now doing the batch prediction, right? How you can do the batch prediction in data science in Fabric. So I'm using Faker library, a Python library, to like create a data set, like a fake data set for the diabetic model. Uh, After creating the data set, I am just loading the model again, which I had registered using ML flow. I loaded that model back and passed my fake data frame to that model and predicted got the predictions. And you can see after getting the predictions, I can um, always store back those prediction as a delta table back uh, into my lake house. So you can see the diabetic process table got created. Now you have this diabetic data set. You can always like and create a report on top of it. The another thing you can see, I talked in the slides about data wrangler and copilot. So in the data processing, we did all the manual steps, right? So you can always use data wrangler to generate a code for you for the data processing, and similarly the copilot, which can help you to generate the code um, uh, for your data processing as well as for training the model, predicting the model. And also you can use as like an interactive Q&A session with your data in Data Science Fabric. Yeah, that's all for today's discussion. Thanks for listening this video. And if you have more question, you need more information on any particular topic in data science and fabric, please reach to your partner technical strategist or your partner development managers. We will be happy to talk more about it.